DevOps is dead, platform engineering is now the new king, right? Platforms is the way you scale. One of the core principles of DevOps is continuous improvement.
Hello, everyone. My name is Vladimir. Welcome back to the Architecture Weekly YouTube channel. Today, we're having an interview with Anton Weiss, a software delivery futurist. Anton, welcome.
Hey, how are you, Vladimir?
Hey, I'm great. What about you?
Fine. Currently, the world as a whole is in an interesting situation.
Yeah, interesting.
But in general, life goes on.
Can you please tell our listeners, who you are, what are you doing, what's your main focus?
Okay, so yes, as you already said, I'm a self-proclaimed software delivery futurist. But basically, I've been dealing with software for the last 23 years. I started out as a software developer, writing code in C and C++ back in the day. And then at a certain point, I realized that the code I was creating, it was taking a very long time until it reached the user. Because again, back in the day, we didn't have continuous integration, continuous delivery. And this lack of immediacy and lack of understanding of the users, it really bothered me. So I found myself doing more and more of integration work. That's what it was called back then. Basically building tools for the other developers next to me, building all kinds of automations. That's how, in the end, I found myself in this field that back then didn't have a name. They used to call it configuration management, and then release engineering, and then around 2009, a new word appeared, and that was DevOps. And that's when I realized that was what I was doing all along, right?
Finally, they invented the word for your work.
Exactly, yes. Not they, it was specifically Patrick, who is now a good friend, Patrick Dubois, the original DevOps Day organizer. Since then, I've been doing DevOps in this or that capacity in different organizations, big enterprises, and then, at approximately the same time, the concept of continuous delivery arrived. So we were already doing continuous integration back then. I already built a continuous integration server all by myself. It was even in the days before Jenkins.
Oh my God. That was a very long time ago.
Ancient history. And then I was leading a continuous delivery unit at AT&T, and then I went to a startup and I was heading the DevOps department there. And then at a certain point, I realized it's time to spread this knowledge. So I became a consultant. And I found myself speaking at a lot of conferences, giving workshops. And then the whole cloud native thing exploded, and there were so many new technologies to learn and spread the word about. And that's basically what I'm doing today. Starting this year, I also started a new journey where I bring the message of Kubernetes optimization to the world, working with PerfectScale, which is a great Israeli startup. My good friends, a wonderful team, great product.
Oh, congratulations on that. So you're explaining people how to use, how to run Kubernetes payloads efficiently. Is that correct?
The whole idea is continuous optimization. Now, this is very close to my heart because, one of the core principles of DevOps is continuous improvement. So DevOps, basically, when we realize we have a problem in the software delivery, in the way we work and collaborate around software, in the way we deliver software, and we realized we need to rethink these processes. And that's basically when the whole ideas of DevOps started arriving. We realized we're not the first ones to solve these kinds of problems. And we started looking back at the issues they were having in manufacturing in the previous century, right? And then we realized that those problems were already getting solved. So once you start scaling any kind of industrial process, you need to rethink your processes, right? And you need to find the bottlenecks, and you need to find the ways to eliminate the bottlenecks. And if you don't eliminate the correct bottlenecks, then you're not improving everything. So we looked back and we looked at things like Theory of Constraints by Eliyahu Goldratt.
Exactly.
And we looked back and realized there was already the Toyota production system and the whole lean manufacturing, lean management that originated from that, right? And one of the main ideas of lean manufacturing and lean management is continuous improvement. Once you've scaled, so scaling is a problem in itself. And that's, by the way, what we're going to talk about, right? So platforms is the way you scale. But once you've scaled, you hit another problem. You've now built something that keeps accumulating technical debt, that keeps growing in complexity, and you need to continuously optimize that, and that's a never-ending work.
Okay. For those of us who don't know what the theory of constraint is, can you please explain what this thing Mr. Goldratt came about?
So basically, we can see any process of production as a pipeline, maybe a stream of events, right? And it has all kinds of stops on the way. So let's think of it as a river, and that river has turns, and maybe some places are narrower and some are wider. Now, if the flow is less than ideal in that stream, in that river, that means there is a blockage somewhere, right? Or if the flow in the pipeline is less than ideal, it means there is a blockage somewhere. Now, this blockage in the theory of Goldratt, it's called a constraint. So basically, this is something that keeps your flow from flowing stronger, from running in its maximum available capacity. Okay, so there's a blockage, there's a constraint. If we take software delivery, for example, maybe your developers are writing code very fast, but then the integration breaks everything, and we cannot release software because when they integrate, a lot of bugs, integration bugs are discovered, and it takes time to find these bugs, and it takes time to fix them. And that means we cannot actually deliver the software. The software is getting produced, but it doesn't reach our customers because the integration is broken. Okay, so then the integration is a constraint. Or maybe there is some part of the system where a very specific, I don't know, C++ or Rust knowledge is needed, and we don't have a person who knows this well enough, then this is also a constraint. So the constraints can appear in all kinds of places in the system. Or maybe we're running on our own data center and we need to add capacity, but it takes time to order new servers and bring them inside. So that's another constraint. Yep. So the theory of constraints says there are a lot of constraints in the system, and the secret to improving the flow is finding the correct constraints to take care of. Because if we look at this as a flow, and so let's say the flow starts here and it flows here, okay? And let's say there is a blockage here, okay? Now, if there's a blockage here, but there are other constraints here, and we start opening the constraints here, the flow becomes stronger, but then it hits this constraint, and we haven't improved anything because this constraint is still in place. Moreover, if we increase the flow here and it hits the constraint, the whole thing may explode, right?
Yeah.
Now, on the other hand, if there is a constraint at the beginning of the pipeline, right, and we eliminate the constraint at the end of it, then we haven't improved anything because there's still this constraint that doesn't let the flow become stronger anyway. So we're just working to eliminate constraints, but not improving anything. So the theory of constraints basically says we need to see our production processes as this value stream, and the value stream mapping practice is very relevant here. Okay, on this stream, we need to find where the actual blockages are, and we need to find where the most constraining constraint is, and when we start improving, we need to start from there. Okay.
That's exactly the point, that we need to find the one that actually limiting us from scaling the system and address one at a time, right? Because once you optimize a single constraint, then another one can be in an absolutely different place. So yeah, and that's the idea basically of continuous improvement, like final bottleneck, adjusting the system as resolving this constraint, and all over again. The listeners can wonder, like, what the hell does it have to do with the platform engineering we're talking about, right? So let's dig deep into this one.
This takes us back basically to that confusion. So at the beginning, I said, okay, I found out I was doing DevOps all along, and that's what I've been doing in the last 10 years. And how does that relate to platform engineering? Because there's a lot of confusion around DevOps and platform engineering today, with all the blog posts we've seen in the last couple of years saying DevOps is dead, platform engineering is now the new king, right? Well, the relationship, as I see it, and recently I had a great conversation about this with Abby Bankser, who is the platform engineering lead at CNCF, platform engineering working group lead at CNCF. We're talking about how platform engineering is basically, it's not different from DevOps, because DevOps is a set of ideas. As we were saying, DevOps is a mindset, right? It got translated into a set of practices, specific tools, specific knowledge, and that's how we got those DevOps engineers everywhere, because it's also now also a profession that we need in order to be able to deliver software in a modern, scalable way.
Mm-hmm.
But as these DevOps engineers continued working, they realized it's not enough to just bring the tools or just improve the processes. Mm-hmm. We need to do this in some cohesive way that would allow us to scale, right? And that's how this concept of a platform reappeared. I'd say it's reappeared, like it's not new, right?
Okay.
So it all goes back to, I suppose, platform as a service. So basically, a platform in a very simplistic way, it's a foundation for something, okay?
Mm-hmm.
So we're saying, here's something we're doing. We need to have a good foundation in order to improve it, and for that we need something to elevate our practices. So this is the platform, okay?
So what you're talking about seems to me like we have like clouds or other providers of some basic services, right? Mm-hmm. And then we start bringing our payloads to, I don't know, EC2 machines and so on and so on. But then we find out that actually on top of the EC2 we start building our own tools to manage the workloads or do the delivery, or to monitor all that stuff and so on and so on. And there, like, we're building a platform on top of a platform, right? So we have like foundation, which is like a data center or a cloud. Then we have the foundation of our own company with our own tooling and practices and stuff. And then we have developers that are leveraging this internal platform that is using the platform that cloud is giving us. Is that the correct understanding?
Yeah, definitely. This is, first of all, this is what happens. You're totally correct. So we're usually using the cloud, but the cloud in itself provides the building blocks. They are already abstractions, but they are not at a high enough level in order for us to be able to use them effectively. So we build a higher level abstraction in order to allow our engineers to be more efficient with this, right?
Okay.
To be able to effectively deliver software.
Okay.
As I see it, okay, we can also look at this like, any process can be looked at in different ways. It's like, light can be particles and waves. So when you look at platform engineering, we can also look at this and see it as an evolution. So yes, we started using the public cloud, and the public cloud allowed us this seamless access to a lot of resources, compute, storage, networking, and with a single API call, you started being able to provision servers, and then we started going crazy with this and provisioning dozens and then hundreds of servers. And then we realized now our developers, in order to deploy their software, where previously it was like, here is my jar, put it on that server, run this script, and the application is running. Now it became very complex. Now it's this is my jar, bake it into an image, and then create an automated process that would spin up these images into a dozen of instances. And then we started to think about stuff like high availability and how do we synchronize state, et cetera, et cetera, et cetera. So there was a lot of complexity growing, right? Mm-hmm. And of course, as a developer, as an engineer responsible for my code, this complexity created a lot of cognitive load that basically wouldn't allow me to be efficient at what I do. So I think the first ones to realize that, okay, first of all, the engineers themselves started building tooling around that. I guess this was originally, the grassroots movement of folks building these things in-house. But then the service providers, the cloud providers, also realized that this was something that the people needed, and that's how platform as a service arrived. Right? So this idea of having an abstraction layer that would abstract out all of this complexity. Mm-hmm. It was saying, you as a developer, you don't need to care about servers, CPUs, memory, networking. Basically, you want to give me your code and you want me to run it, right? So platform as a service arrived. Heroku is a poster boy of that. And of course, there was a lot of buzz around that, and all of the big cloud providers, they all came out with their own versions of that. So Google App Engine was hot for a while, and then Amazon came along with Elastic Beanstalk, etc., etc., etc. The trouble with that, so there was a lot of buzz about it. There was such a huge promise. So basically, at a certain point in time, you could hear the marketer saying, in 5 years from now, nobody's going to use EC2 instances. Everybody's going to run on a platform as a service because nobody needs this complexity. Just give me your code and we'll find a way to run it. Mm-hmm. So the trouble with that is we found out it's impossible to build a generic platform that would fit all of the different use cases. The problem with that was that, coding and software engineering is a creative profession. And we want to continue being creative. Now, a platform, or any abstraction layer for that matter, it allows you to be productive by applying certain constraints.
Yeah, right? It is.
So we were talking about constraints previously. There are constraints that are blocking constraints, but there are also enabling constraints in the system. Okay, so the platform is all about building the enabling constraints, saying this is the correct way to go. So because you don't want your flow to explode and flow in all different directions, you still want it to follow a certain direction.
Yeah, so it's like the opposite. It's a directing constraint. It's like, hey, you can go like 100 ways, but all of those are like not optimal. And there are one or two that if you can go by, you can focus on doing your things and not choosing all those directions at once.
Exactly. So when you try to build this platform as a one-size-fits-all, you always find yourself either building something too narrow, and then it's okay for the most basic use cases, but once you start being more adventurous, you start hitting the walls. And I've seen companies doing exactly that, small startups starting out with platform as a service and then realizing that in order to do anything not ordinary, anything special, anything that would provide them their unique competitive advantage that any business wants to have, it becomes very hard because the platform is constraining them. Okay, the enabling constraints at a certain scale, they become blocking constraints. Okay, on the other hand, if you don't provide the enabling constraints, then the value of the platform becomes very low because it's very easy to shoot yourself in the leg.
Yeah, that's true.
So that's how platform engineering came along. That's when we realized that in order to actually be effective with platforms, we need to build our own platforms. And that's not for everyone, of course. So platform engineering is about scaling DevOps. So if you're an organization, if you're a small startup with, I don't know, a dozen developers and maybe one DevOps engineer, I always say the public cloud is all the platform you need. Okay,
Yeah.
take the public cloud, maybe use a PaaS, maybe use function as a service.
Yeah.
Wrap a little bit of scripting around that, build generic CI pipelines, and you're good. And that's all the platform you need.
Yeah, this is what we're doing right now at Supplied. So basically, it's a small startup in the compliance field. It requires just verifying some documents and building and generating some XMLs. And we're just having like 5 Lambda functions, a couple of S3 buckets, DynamoDB tables, and like 2 or 3 GitHub CI actions, and that's it. And it's all running. You just need to commit the code, and it's bam on the production. That's it.
Yeah, and basically, if you have good enough engineers who are curious enough and responsible enough, you don't even need specialists there today because the tools have become very accessible. So just take great coders who are also okay with doing some integration stuff, and that's all the platform you need, basically.
Yeah, true in my experience as well.
Today we call this the minimum viable platform. So you already have
okay. Another MVP. Yeah,
another MVP. Okay, but of course, once the company starts growing, this thing doesn't scale anymore because we start having different products. And today with the microservices, we want to be polyglot shops. So we have different languages and different frameworks and different delivery practices. And of course, I don't know, we may have front end that we deliver to S3 buckets and back end that runs, I don't know, Node, Go, Rust, you name it. So we start to have a lot of variety in our stack, and building something small and custom for each one of these components becomes unscalable. Okay.
Yeah.
And having the same people who are doing the code, taking care of the delivery practices, doesn't scale well. And the whole idea of shift left starts breaking up unless we build a cohesive platform. So unless we stop for a second and start asking ourselves, how do we want to work around here, right? What are the practices that we find productive? And basically, how do we want to collaborate? And that's basically the definition. If you look at the platform engineering white paper by the CNCF, that's basically what it says. Platform engineering is a set of practices that enable organization to have collaborative software delivery. So the platforms are there basically for humans to be able to collaborate around software delivery.
Okay. So rephrasing what you have said is like when we have growing people and more products adding to the company's portfolio, then we see that like people need to have some tools not to focus on the delivery software but rather developing software. And this is where the platform is so useful because it can provide the practices and foundations and tools so that people can just write the code and ship it to production and not caring about like how exactly it gets delivered or run in the production. Is that correct?
In general, yes. I'm learning this thing called nonviolent communication by Marshall Rosenberg.
Okay.
By the way, I think there's a lot of psychology in platform engineering and in DevOps in general. And the thing with saying we don't care as how something is done, I think there's it's problematic, right?
Okay, it's a good point. Good point.
I think what you're saying there is I don't want it to be painful. Okay?
Yeah.
Because when the delivery becomes a pain, then of course you start avoiding the delivery. Okay, so I think that the goal of a platform is to make software delivery enjoyable.
Okay.
And then you can care about that, because to care about something is to like it. So in English, it's interesting. I care for that. I like it. Okay, and I don't care. That means I don't like it. So yeah, I think the idea of a platform is to take something you don't like and turn it into something you like to do.
Okay. So you mean like not caring is a bad thing? You should care, but you shouldn't be torturing yourself while doing so. So it should be enjoyable. Okay.
There's this saying, platformers are about making the right thing easy.
Okay. Yeah, that's another good point. Mm-hmm.
Yeah.
Okay.
So basically, that's why, for example, I don't know, monitoring, observability, it's also a part of a platform. Even though, it's maybe we need this in order for the systems to be running smoothly and in order to be able to troubleshoot, but then it's also about collaboration, right?
Mm-hmm.
It's about us being able to access the information. Now, it's not only access the information. So great observability is not only about collecting as many data points as I possibly can, because then I just find myself with more complexity.
Mm-hmm.
Great observability is about defining what we need to know about the system to be able to effectively troubleshoot that, and that knowledge is a collaborative thing. So that knowledge is something we define as an organization, because if somebody looks at a dashboard and understands what's happening, and then the other engineer looks at the same dashboards and he has no idea because he hasn't created that dashboard or because the dashboard isn't intuitive for them, then this is not observability, right? This is observability for just one engineer, and when that engineer is sick, there is no observability suddenly.
Yeah, because nobody is observing, actually. Yeah, that was my next point, because I like what Charity Majors is talking about. This is that you need to understand the system you're running, and you actually cannot run the system if you didn't create it, didn't write it, right? And you cannot write a system if you don't run it, because you don't know what happens in production with that. So that means that it's impossible to evolve it properly, and that's kind of a big blocker. And this is a huge problem with the DevOps, right? Because it now demands the developers to understand the runtime as well as the folks that were originally running the runtime, and that brings a massive cognitive load on those. Like, should platform engineering resolve this problem for us finally?
In general, yes, platform engineering does resolve the issue with cognitive load by creating a user experience. So basically, there's a lot of talk today about developer experience, specifically in this platform engineering field. Because again, we said platforms are there to let us collaborate better around software delivery. And folks who collaborate there, they're engineers. By the way, I don't really like when we frame it as developer experience, because definitely not all the folks who are involved in delivering software are straight software developers, right?
Who the other then?
There are also automation engineers, you can see them as software developers, but they're maybe more about configuring the tools, and the configuration managers and release engineers and the ops folks themselves, right? So if we had
Okay.
that devs versus ops dichotomy in the past, now if we suddenly start talking about developer experience, then what happens with the operator's experience?
Yeah.
Do we care about that, or don't we? Or
Yeah, screw that, folks.
but again, coming back to your question, the platform, and we start realizing this more. But by the way, something again to say, platform engineering is a very new discipline. Okay. There's a lot of buzz around it, but it's only being created right now. We still don't really know very well what goes into that discipline, what goes into this set of practices. It continues evolving.
Okay.
So some concerns we can already say that they need to be there, like the good observability practices, and continuous delivery has been well defined, right? And developer experience or engineering experience is becoming a part of that. So one part of that is understanding how people work and providing the correct filters into these information that keeps aggregating inside the system in order for them to be able to easily find what they need, to easily understand what they need without the need to maybe understand all of the details. So I think the desire is still there for us to iteratively understand all of the intricacies of the platform, and that's probably what Charity is talking about. We need to have this understanding, but not everybody needs to have this understanding.
Okay.
The thing we really need to have is this language that we can talk in about the system, this common understanding of what is the thing that we're talking about.
Can you provide
the processes that would allow other people to acquire this knowledge?
Can you provide an example?
Okay, if somebody knows all of the details and somebody doesn't know all of the details yet, but he can have, or he or she can have that access.
Okay, can you share an example, because I'm not sure I'm following.
Okay, yeah, that's probably a little bit too abstract. So coming back to Charity, what Charity says. So in order to understand the platform, you need to build it, right? In order to build it, you need to run it, or
it was like you cannot create a system until you run it, and you cannot run it until you create it.
Yeah, okay. The chicken and egg problem.
Yeah, exactly.
But in general, and we said that creates a problem around the operators who need to run the system because they're not the ones creating it. And that that basically takes me back to the original DevOps, where the DevOps definition came from. So it was all about that talk at the Velocity conference, where the folks from Flickr, John Olspor and Dave Hammond, they came and said, we at Flickr were able to deliver software to production 10 times a day. Why? Because our devs think a bit more like ops, and our ops think a bit more like devs. So they understand each other's concerns, and that's what allows us this smooth delivery and this faster iteration. Because the devs have very fast access to what's happening in the production, and they are able to troubleshoot quickly. And on the other hand, the ops are understanding what devs are trying to do, and that allows them to build the foundation for that code in a quick and smooth way, and to expose the information, specifically the information that developers need. Okay. So I guess the answer is, we don't need everyone to know everything, but we need to be able to communicate. And the platform is there to allow for that communication channel, that common language that we can talk about our systems in.
Okay, so it's not only about the tools, but about creating a common communication space where everybody can understand what's happening with with the domain of another folks.
Definitely, and that's why the internal delivery portals are so much in focus today, because we're starting to realize that, okay, we've built the platform and we know how we provision our cloud infrastructure, and we're using Terraform, Pulumi, Crossplane, you name it, and we know how we do CI and maybe CD. We have our GitHub Actions or Jenkins. And we know how our dashboards are built, but then we have a lot of disparate pieces of this story, right? And it's very hard for everybody to know where everything is found. And then there are also, of course, a lot of context switch cost, because we have so many systems. And now what we're trying to do in order to cater to that engineering experience, we're trying to tell one common story around that platform. And that's the idea of an internal delivery portal. Let's try to see how all these different tools and systems that we've built, that our platform consists of, and again, platform is a set of tools, a set of practices. Let's see how we can now unify all this to make one cohesive story that we can all tell and continue building.
Okay, I think I understand what you're talking about, because we have something similar in Bolts, where like you can have a pull request committed, and then you go to this developer portal, okay, and then you can deploy it. It will roll out to like a test environment. Then you can monitor it right there, see the logs, like see the state, like see the state of the nodes, how it's going. And then if you see that everything is fine, you can press a button, roll out to production, see how it rolls out. And if you see a problem in production, you can roll back, not switching anywhere else, right? And then you can see a state of your cluster or like state of services and so on and so on. So this is what you're talking about, like internal developer portal where you can see everything in one place.
Yes. Basically, bring all of the tools I need to do a job into one place. Creating that working environment. Okay. So like an IDE, but that also spans into production. And brings me the observability data and allows me to also communicate with other folks, because that's what happens in a company, in an organization. I'm not building my code myself, right? I need other people to do my work effectively, and I need to be able to communicate with them. And this also probably stems from how we expect our communication today to happen. So we want it to be, on one hand, very immediate, but on the other hand, asynchronous, because that's what allows for robust but performance systems. And coming back to the topic of your show, architecture.
Yeah, exactly. Yeah, I think
we want this to be event driven, basically.
not every time, but yeah, frequently we are. Okay, good. Let's talk about the expectations from a platform engineer, like in 2024, right? Because there's so much complexity. There are like several major clouds. There's Kubernetes. There's function as a service things. There's those distributed systems. There's those observability frameworks. And there's so much tech right now in order just to run a single service in production, let's say, right? So like you can open just your node modules for a Node.js project and see like how much you need to do that, all of those. So what are the expectations from the platform engineer? Like what do they need to know, and what skills do they require to do their job effectively?
Well, I think that there are some, basic skills, like understanding what continuous integration is and how to build a CI pipeline. Now, most of the tools we have today, they're pretty similar. So once you understand the basic concepts, it's learning a specific tool. I don't know, be it Circle CI, GitLab CI, GitHub Actions, or even Jenkins. Even though Jenkins, it's a bit older and it allows for more complexity, for better or for worse. But still, again, if you understand the basics, why even we do continuous integration and what are the basic steps involved in that, then you're good. Of course, basic operating system, and today specifically, if we're talking about cloud native ecosystem, then Linux basics. That's definitely something you need to have. The deeper, the better, by the way, I think. And cloud infrastructure, understanding how APIs work. And these two things are inseparable. So in order to understand how modern cloud works, you need to understand how APIs work.
Okay.
And you need to understand the communication protocols, at least the basic TCP/IP and HTTP.
Okay, so what you're saying is like building a foundation understanding from like the very low level, like operating systems, processes, memory, and so on and so on. And then the huge part is the networking. So understanding like the OSI model, right, and understanding what network protocols is doing on each level and what problem do they solve. I think it's impossible to reason about any computer system without understanding like these things.
Networks.
Yeah. And like once you go to the cloud, then you stumble upon this virtual private network. How you gonna comprehend this without knowing like how basic networking is operating? Okay.
Definitely. I experienced this firsthand. So, back when I started, we were usually running software on a single server, and that was enough. And then, as time went by, I needed to deal with networks more and more. And then when I started learning Kubernetes, I suddenly realized I don't understand networking at all. There was so much virtualization going there, and I needed to relearn this whole thing again.
Okay. How do you learn as a platform engineer then? Right now, as like so many skills are required and like so much understanding it has to be built.
Well, the amount of information is, of course, overwhelming. And I think the problem today is, again, not how to access the needed information. The problem is, first of all, how to find the discipline to learn and how to find good enough sources. I think whatever is coming today out of CNCF is of great quality. So basically, attending CNCF events and meetups is a great way to learn about stuff. And then when you need to actually learn specific technology, most of the tech today has great getting started tutorials, and it's always okay to start with that. But I'm also a trainer myself.
Okay.
I like teaching. I've been doing this for 10 years, something like that. We also, as a consultant, I also had a consulting agency, and we do also technical training on cloud native technologies and continuous integration technologies. And so a little self-promotion. If you want to get your team skilled up on any kind of this tech, Kubernetes, CI, infrastructure as code, we provide these courses.
Okay.
So reach out to me.
But that's for seasoned developers already. Like if you want to upscale, not to learn from the zero, from the scratch, right?
And if you want to learn from scratch, then definitely there are a lot of resources. So there is a what is it called? Free Code Camp.
Okay.
And well, cloud providers, Google Cloud has a lot of courses on Coursera that you
Yeah,
can
they
start
do.
with. Even me myself, when I realized I need to improve my networking understanding, I took a very basic, network fundamentals, because I never actually learned this. Everything I learned was learning on the job, so I didn't have a very basic understanding of what TCP/IP is, or how the OCI model works, OSI model works. So I basically just took a course, and it's all available there. I think this is the way. So one of the things is learn on the job, try to understand what other folks are doing, and implement that in your everyday work by doing that continuous improvement. You realize there's this process that's taking a lot of time, and it's slowing everybody down, and you want to automate it, and you realize that you could have used Terraform for that, and here's your break at trying Terraform, and maybe letting that spread to all the rest of your processes eventually.
Yeah, learning on the job is important, but learning the foundation is even more, right? So I agree with courses a lot, because like the way how I got my certification, Google Cloud architecture, was exactly through the Coursera course. So that's like an established way. I always admire the folks that are like grinding the certifications, like five certificates, 10 cloud certificates. That's like, okay. I always wonder, like, do you do it just to hand it on the wall, or like there's some practical sense how to why you're grinding all of that? But indeed, that's a good way to learn, because it imposes some discipline on you, because like if you have an exam incoming, then you kind of have to study, right? That's what exams are for. Okay.
I think the correct, again, from my point of view, balancing this, course learning with building stuff yourself is the correct way. By the way, another way to learn is, of course, participating in open source.
Okay.
That's something not to miss. It's a great opportunity, first of all, to build your platform engineer or developer resume, because once you've participated in an open source project, that's always something that's very appreciated by the employers.
Mm-hmm.
And of course, it's a great way to learn by reading other people's code, by submitting pull requests and getting feedback from seasoned engineers. I think that's irreplaceable. Of course, the best thing is if you also have a mentoring program at your place of work, because we as humans, the best way we learn is by mimicking other humans' behavior.
Yeah, that's very true. Yeah, unfortunately, not every company has this mentoring thing, but yeah. Okay, thank you very much. I think the last question that I can ask, because we don't have a lot of time, is like, how do you see the future of platform engineering? Like, what trends do you see? Where are we going with this?
Yeah, my favorite question. I also, I have my own show called DevOps Shorts, and now it's slowly becoming Platform Shorts. And the last question in the show is always about the future. How do you see the future? So the way I see this happening is that I think the whole thing about building platforms, and I agree with this again, is understanding the human experience, learning the human experience. And machine learning is basically a lot about that, right? So it's about machines trying to learn the human experience, or us humans trying to learn the machines what it is to be human. And I think in general, of course, our platforms will become smarter, much more adaptive to what we do. I think the goal of integrating machine learning into platforms is, first of all, to help us identify issues and problems in the most immediate way. And also, we'll see much more intuitive interfaces. So yes, we all want us to be able to talk to platforms, and I think we're already seeing some glimpses of that. Folks are releasing all kinds of LangChain like tools where you can talk to your systems in a human language, and the systems understand what is it you want to do. And even before that, we were talking about how a platform is a common language for us to collaborate around. I think what we'll see there is each organization will find itself building its own model of communication and training that model in order to continue evolving that thing that they're doing. And even today, platforms, basically one of the things why we're building platforms. So as we said, in order to be able to deliver software easily, to collaborate around software, but we need to remember that there is a business context there, right? We're still competing against other businesses. And why we're building platforms is also because we want to stay competitive, and a great platform becomes a competitive advantage.
Yeah, true.
Like having better tools makes you a better carpenter. I don't know. Platforms are tools. So in the future, as I see it, the smarter your model becomes, the better you become as a company.
Yeah, that's a nice insight. Like speaking to the platform is like asking, hey, I want this cluster to be, I don't know, replicated in a test environment. And then the platform is saying like what you need to do. That would be a nice thing.
And that opens new possibilities. So like for today, we want to get better at our platforming. We look at Google. And then I, as a platform engineer, I need to go and read their book and understand how that is applicable to my own models of delivery. And then maybe, I don't know, mimic some of these practices, and maybe understand that some of them are not applicable to what I do, and then invent my own. And that's basically how innovation goes, right? We take something from other people and we add something of our own, and that's how we create new stuff, and that's how we all evolve as a humanity. In the future, I think it will just become faster. Okay. This path to understanding what's applicable and what's not, the discovery process will become faster. But ultimately, the decision still stays in the hands of humans, because otherwise these decisions are worthless.
That's true. Like machine cannot make a decision because it cannot be held accountable. So
I think the way I see it, the machine can, and they do, but the machines can only take decisions that are directed by humans. Okay, so basically, we can create a bot, a trading bot, and we can tell it when a value of a certain
asset
share, certain asset goes lower than a certain price or higher than a certain price, then sell or buy. And it will do that. It will take the decision because we've defined what the criteria for decisions is. Okay, but still it's up for us to define the criteria, because the machine doesn't have a good enough idea what we as humans currently want.
True.
The machine doesn't know if there is a war around, if we're healthy or sick. and ultimately that's what impacts our decisions.
Yeah. All right. So we're out of time. So I want to thank you a lot. So I learned some new perspective about the platform engineering, how to think about it. So that's valuable for me, and I hope it is valuable for our listeners. So thank you for watching.
Thanks.
Do you have any?
Thanks.
Yeah. Do you have anything you want to say?
Just that I love creating software, delivering software, and building platforms for humans to be more effective at doing that. And if you're listening to that, you're in the same industry as I am. I think you're very lucky, and just appreciate that.
Cool. Thank you very much again. And yeah, see ya next time.